Hello everyone, my name is Odarike Charles and today I'm going to show you how you can use Python to do polynomial operations. One, you can use Python to find the roots, factorization, division, and also the remainder theorem application. So to do that, you're going to install the following libraries. So one, you're going to install NumPy as NP, you're going to install SymPy as SP, you're going to install SymPy. Then from that, I'm going to install matplotlib for plotting. So import matplotlib.pyplot as plt. Then you're going to import field warnings. Then I'm going to do what we call warnings.filter. This is not a must. Filter warnings. Then you're going to ignore that. So you're going to run that cell. Yeah, so after running that cell, now is to define. So we see this polynomial contains the variable x. So we are going to import. So if you don't know more about that SymPy library, you can come to documentation. You can say SymPy documentation, and you can be able to have a read on it, see what it does. But SymPy just a symbolical library. Yeah, so we do symbolical operations like multiplication of expressions, anything that is symbolical, not analytic, not numerical. So from this, you're going to define a variable x. So to define a variable x, you're going to say from sympy sympy.abc. ABC, it contains all the symbols that are used in engineering, science, mathematics, everything that's there. So you're going to import only x. We can import omega so that I show you what it does. So when you type omega, you can see what it is. It's just an omega. If you install something like say theta, and type here theta, you see, so it contains all the symbols. So from this, you are going to define a simple, let's define this one, x squared plus 3x plus 2. So you can just, if you are doing maybe you want to make a good documentation about your work, I'm going to use something called latex, and this is not a must for you, but just to do a good documentation. So I can say, example, we have this kind of an equation. So let's say it's just something x squared plus 3x plus 2. So if you have such kind, so you're having that. So let's define that. So you can say p is equals to just x raised to 2 plus 3x, 3 multiplied by x plus 2. So if you do that, we find this. So we want to find the roots. So to find the roots, what you do, you are going to solve. So when you solve, this equation will be equated to 0, so that we can have an equation from this. So we can say an equation. So you can type equation, then you input the expression. Then, you put the equation, then equals to. So that equals to is comma equals to 0. So we see it's x squared plus 3x plus 2 equals to what? Equals to 0. So from this, we want to find the roots. And you know that we can use quadratic formula, you can use completing square method to do that. If you are in numerical, you can use other method that can be used to solve this. Okay, so to do this, you're going to say sp.solve, then you shall input the expression that is p. So you see the values, the roots of that is from -2 and -1. It's the value, the roots are -2 and -1. Very, very simple. So let's say you want to maybe visualize it. You want to visualize the function. So to visualize the function, something easy, what you do, just say sp.plot. If you want to read about it, you can have that. Then you can do that, enable, so you can read about the function. If you don't know the parameter that the function needs, the argument that are needed, so you can just have that. So you can say then p, then the title. You can have the title, like just say plot the expression. Then you can have x limit from -4 to 4. Then you can have the y limit from maybe -2.5. I'll explain why I'm using that. So yeah, so from this it will process. I just have to wait. Yeah, so you see the roots are from -2 and -1. The roots are 2, -1 and -2, so that you can be able to do that. Okay, so you can see plt.show, yeah, to look like that. So if you want to make your plots feel like that can be used maybe in documentation, in papers, in reports, you can come and install what we call import sans plots. Okay, so if you do this, you can just come and now implement that, but I'll show you at the end of the video. So this is that we are the roots are fine. So you see how you can be able to find the roots. Just have the expression after expression. This is no use. Just I wanted to show that you are putting that function to 0. Then you can just have sp.solve. Then you can have the roots as -2 and -1. So this is only that is needed. It's now what if you want now to maybe find factorize? You have been given such kind of an equation. Now they have told you to factor that function. So to factorize is just simple. What you do is just very simple as 1, 2, 3. So to factorize, you can just say sp dot fact. Let me delete this so I can just clear the cell output so that yeah. So you just say a factor, then f, no p. So it will give you x plus 1, x plus 2. Yeah, because you have got the solution as x is equals to -2, x is equals to -1. So when you want to expand that, you'll have to do negative x is equals to -2, then you say x is equals to 2, then x is equals to -1, x is equals to 1, is equals to 0, is equals to 0, then you expand. So if you want to expand this expression here, very simple. What you do, you just say sp dot expand x plus 1. Let me get this one to maybe a solution. Let's say this one is p f. Let's say this one is f. Then we can have that f. So we want to expand that f. So to expand, just say xp dot expand, then f. So you see it has expanded the expression. That's very simple. Now, after expanding that, let's say you have an equation. It's a polynomial expression that when you do the factorization, you'll get a complex thing. So to do that, let's say you have such kind of an equation. Let's say we have this. Let's say we have this kind of equation, raised to squared, then plus 4x plus 20. So yeah, you have this. Then you have been asked to factorize. Sorry, you have been asked to factorize. So to run that, yeah, so I've been asked to factorize that. So to factorize, we can have f is equals to x squared plus 4 multiplied by x plus 20. So we can have our expression as that. So we want to factor. So to factorize, you do sp dot the same way, sp dot factorize factor. Then you have the f, but because it may contain the complex, we have to have an extension. So you say extension is equals to sp dot I. I means the complex, that I or j. When you do this in circuit analysis, use j. When you do mathematics, some people use j, some use I. So that. So you see, it will do the factorization. Good. Now, we have done with factorization. This is what the part for factorization. This was to let me have a good documentation. This was to have uh, finding roots. So, finding roots of a polynomial expression of a polynomial. Then after that, we came to factorization. So we can have here a good documentation, then we can say factorization. Then after that, now we come to polynomial division. So you can say polynomial division. So example, you have been given such a polynomial. You have been given x. You have been given x squared plus 3x plus 1, then divide by x plus 1. Okay, plus 1. So they have told you now do the division. So to do the division is just simple. We can now define the numerator, which we call the numerator. This is the same as x squared plus 3x plus 1. Denominator is equals to x plus 1. So we can come up with the expression that is numerator divided by the denominator, then we can have the f. So that's the expression. So from that, we can do the factorization. So we can have not factorization, the division. So we can have the quotient and the remainder, right? So is equals to sp dot div, which means polynomial division. So you can have the numerator, denominator. So you can have you can see what the quotient is. Quotient x plus 2, then the remainder is -1. So this is how you can be able to use polynomial to do the division. Very, very simple, very, very simple. You don't have to do much. The only thing that you are needed to do is just to have define the expression, then get. Then, now what about remainder theorem? So let me have just a documentation of that. What about remainder theorem? Okay, let me run this. So all this just to do that. But what if you want to do the remainder theorem? So do the remainder says, the remainder theorem says that when a polynomial p of x is divided by x of that, the remainder is equal to, you plug in that value of a into the polynomial. So let's say you have a polynomial of this, p is equals to what? X squared plus 3 divided by x. The same way we are doing x, then plus 2. This is the polynomial, sorry. This is the polynomial. I think I have my caps on. This should think, oh, caps. I have caps on. So this is the polynomial. Then we want to do the like the divisor. The divisor equals to what? X minus 2. Or x minus 1. Sorry, it's x minus 1. So have that. So you can have the divisor. Yeah. So you want to divide. When you divide, you just say quotient, remainder, sp dot div. Then we have the p and the divisor. So you have the quotient, you have the remainder. Now let's do it the way it says. It says that when we plug p, then we plug, because this is x minus 1, so we plug p of 1. So they say p of 1 will give us 6. So let's see if it's true. So we have to substitute. So just substitute, say p, substitute. Then where this x, plug in 1. So you get the value is 6, and this is how you can be able to do. I know maybe you have not gotten, but I have the link to this, I have it in the video description. So you can just have a look at it, and please like, share, and subscribe. Yeah. If you need any help, you can, or you need I do a video on a different concept, I can do it. It's only that is for that. Thank you. Yeah, I need to- I'm not sure.